All right. Hopefully I'm back. I'm very sorry. OBS crashed, which is not what I was hoping for. So that's pretty tragic. Uh, my significant apologies. I'm very sorry. I'm hoping I am back, but I haven't yet to find myself. It says I'm not dropping here. This has been a beautiful technology day. And I really wanted to go over more stuff. I might just be making a video unless I can find a way to get live again because my internet is papega, for lack of a better word. Uh, I am certainly hoping, but not super confident, that things are fixed. And if so, very sorry to those of you who are watching this right now and listening to me ramble to myself. All right, it looks like I'm back. Did everything just die? And my OBS totally crashed. So I'm really, really sorry. And this has been an absolute disaster of technology day. I was really hoping this would be useful, but instead it's been frustrating. So that's wonderful. I just updated OBS, so that was a significant mistake on my part. Uh, so where were we when I left off on the other stream? I had just done like a baby one of these, and I was heading over to do questions off the review. uh, I was talking about question 8 when everything went bananas. To review what I had said about 8, step 1, build the equation, which is plug in the stuff from the question into the S of t equation. Step 2, take the derivative of that to find the velocity equation. This is like our position equation. And use these to solve both parts of the question. So this is a derivative question. It's just a little bit of a veiled question. And again, I am very sorry about the technical difficulties. I pay so much for this internet, and I guess, I don't know who to blame here, OBS or Comcast. Anyways, 12, I guess, is our next one. In 12, I did product rule and quotient rule, but that's maybe silly. Maybe it's better not to do that, so I'm going to not do that this time, unlike what I did in the review. If I do that, I just simplify this to this, and now I just have quotient rule. I just distributed the v to both terms. If I take the derivative of this, I get 7 minus, and now I have quotient rule madness. Yeah, what are these things in my chat? Hey bro, keep grinding. If you play Fortnite, what is this garbage? All right. Bottom d top minus top times the derivative of the bottom all over the bottom squared. Looks like that. Yeah, TJ, I don't 100% know how to do it, and I want to kind of focus on math right now. If I simplify this, I get 5v minus 5v on top. So I really just get 7 minus 10 over v plus 2 squared. That's probably the best answer for this question, is this. Which isn't perhaps how I did it in my key, because I don't remember doing this earlier today. It turns out there's a lot of ways to skin a cat, and this is one of them. That's kind of a grotesque analogy. 14 is the next one asked about. In 14, we have a baby bit of product rule here. So if I product rule that, I get 8 sine s for derivative of the first times the second, plus 8s, which is the first thing, times the derivative of the second, which is cosine of s. And I realize this s issue is going to be an issue, so I should put parentheses around my insides. And then I'm going to have plus, or really minus, because erase all ink. No, I really don't want that. So, minus 3 sine s for the derivative of positive 3 cosine s. And this mess is the answer. There's not really anywhere to go from here. You just get your two product rule parts and subtract the last part there. Okay. And our last piece is 16. It says the radius of a right circular cylinder, so cylinder, pi r squared h, is our volume equation. And then I just plug in this for radius and this for height. If I do that, I get v equals pi times 3t plus 5, because root 3t plus 5 squared is just 3t plus 5. Height is t to the fourth. And then I just simplify this to make my life easier, and I get 3 pi times t to the fifth plus 5 pi times t to the fourth. And this is what we take the derivative of with respect to time, and that's just the answer. So dv dt is going to be 15 pi times t to the fourth plus 20 pi t cubed. So this question looks like a related rates question, but since time is our input to the radius and the height equations, we just kind of bail out here. You could get dt's, but those are a little silly and superfluous because dt is 1. So that gets that. Sam, your please have been noticed. All right. Can you do one finding a tangent line equation? Yes, I can totally do that. So, if I go in and do a tangent line equation, do I have one of those handy? I actually might have one of those handy, because I used to use different worksheets. So I have stuff available here that's, now that's more related rates. Am I smarter than a toaster or less smart than a toaster? It seems like I'm less smart than a toaster. So let's just make up a random one. All right. Okay. So usually they give you a function. Like the really janky ones that throw people for a loop. They give you a function. I'm not going to do anything like the one that was on the review. So I'll do something different, like x plus 1 to the sixth or something like that for my function. And then, okay, so I need to make this kind of reasonable to solve for. Okay, yeah, we're just gonna make this super lame. And I want this to be parallel to y minus 6x equals 4. So this is really similar to the one in the review. So I have something I want to be parallel to, so I know what my slope needs to be. If I add 6x to both sides, I get y equals 6x plus 4, which is 6, my slope. And then to figure out the point at which it is tangent to this graph, or the point at which something parallel to this dude would be tangent to the graph, all I do is set the derivative of this line, which is 6, equal to the derivative of this, which is Okay. Okay, my sound cut out again, but I haven't dropped a frame. And we're still recording, so we're still here. My computer freaked out, but it has RAM issues. So I'm assuming I'm still live and streaming here. All right. Anyways, back to that question. I need to finish this by finding the y value. So y is 1 in my original curve when I plug in 0 for x. So I know this goes through 0, 1 and has a slope of 6. And this is where you're home free. It's y equals 6x plus 1 because I gave myself a y-intercept equation. And I was able to get to that answer. I'm going to try to find my stream. Okay, sick. I found it, and it's all good. Holy smokes, what a day of internet and trash. I apologize for the jankiness here. I can't afford a nice mic. The issue is not the mic, it's whatever the pickup is on this and the OBS and stuff. Like, it's cutting out of OBS, but the mic is still working in the sound. Anyways, the issues are maybe related to my Surface, which is a little sad. Anyways, as far as a question that would be super nice to take a peek at, oh, can you do 2 on the review packet? I would like to do that and redeem myself. Okay, so question 2 is exactly the question I just did, except with different numbers. So I'll take a quick peek at this, but I don't really want to finish it because I just did this other really similar question. So similarly, you solve for the slope in the right equation by adding y to each side. You take the derivative of both equations and set them equal. So 48 equals 12x squared. When you solve this equation, you can get, well, you divide by 12, and then you can get 2 or negative 2 as answers to this. And then once you get these 2 answers, you use either of these, plug them back into the original function. So if you plug in 2, you get positive 32. If you plug in negative 2, you get negative 32. Either of these points, negative 2 comma 32 or 2 comma 32, can be used with that slope to find a tangent line equation. So there's actually 2 correct answers to this. So one of them is y minus 32 equals, and I lied, I guess I did the entire question here, x minus 2, or y plus 32 equals 48 times x plus 2. And either of these was entirely legit. Because it turns out in x cubed functions, they look a little something like meow. And where you have a nice steep slope could be here, or it could be up here. And so those are the 2 points we found. This is like negative 2, and this is like 2. So that's my super legit drawing that explains why that is the case it is. Both of those have a slope of 48, roughly, in my crappy drawing. And get us there. Can you do 28, 29, and 30? Yeah, answer key. Although this answer key is trash, and a lot of them like don't even actually answer the question. That's why I did my own. Oh, all the related rates ones. Tell you what, I'm going to leave these in here. Okay, I'm happy to do 30 since that gets a double. I want to do a different question that's really similar to 29 that I did prepared specifically for this. So as long as my sound sticks with me for a little bit, I'm hoping to get through that one. So in 30, it just has a radius of a circle. So, and an area. So a equals pi r squared is our beautiful equation that solves this. If you take the derivative, you get dA dt equals 2 pi r dr dt. And then you just plug in stuff. So dr dt is negative 5. R is 6. I get 2 pi, and you just multiply those. You get like negative 60 pi or something like that. So I had an issue with 22. No meme. Okay. Finally, somebody's not memeing. So yeah, this was negative 60 pi. This thing's shrinking at that fast in centimeters squared per second. Again, I want to do a cone question, but it's like a free response question, and it should answer questions that are very similar to this, because this is kind of our vintage boy. One warning on this question: the radius is 6, not 12. If it's 12 feet across the top, the radius is half that distance. So if you got a different answer than me, that could have been it. The thing that makes this one especially janky is 6 over 19 is a pretty awful R over H. It makes the answer a little nasty. Okay, 22 is our no meme. All right. For 22, you get a calculator. That makes this so much easier. Uh, you take a derivative of this. It's 6 tangent to the 5th of x times secant squared of x. If you're like, Mr. Kennedy, how did you get that? This is tangent of x to the 6th. Plug back in. Let's see if that worked. It did. Wow. Uh, yeah, I had none of these problems last time. Is there a memory leak on this stupid surface? Maybe I can figure out a better way to pull this off. Maybe I'll invest in that at some point. Uh, but to finish this off, I wanted to check out. Where did I want to check out? I had some related rates questions that were perfect to look at with. No, not that one. I think it's this one. Related rates. No. There we go. This has a cone question, and this is an actual AP question that was pulled off at some point. So this would be new and very applicable to the question that was asked. All right. A container has the shape of an open right cylinder cone, as this is shown here. So that means our R is 5, and our H, R is 5, and our H is 10. This makes our R over H relationship much easier than the one in the packet. It's 5/10, so R equals 1/2 H. No, I need this eventually, but I do not need this right away, because it just says find the volume of the water in the container when H equals 5. So when H equals 5, R equals 2.5, because R is half of H. Oh, maybe I did need this ratio already. And then you just do 1/3 pi times 2.5 squared times 5. And this is an example of a AP part of a question that requires 0 calculus. All right. Yeah, whatever this is the answer. Yeah, I'm too lazy to figure that out. It's some decimal. And you would get a calculator on a question like this, or they'd let you leave it like this, which is sweet. I didn't need to indicate units of measure, so this would be in centimeters cubed because I'm just finding volume. Again, no derivatives yet. Then it says find the rate of the change of the volume in the thing when h equals 5. Now, I have water evaporating at this constant rate. That means I'm losing volume. So I'm solving for dH, yeah, VDT here, when dHdt is negative 3 over 10 uh, centimeters per hour. All right, so I get my V equals 1/3 pi r squared h equation, and I wipe out that r with a 1/2 h. You get this, but this kind of sucks, so let's just make this an h cubed when I plug in the 1/2 h right here. All right, now that I have this beautiful equation, I just mob it. dv dt equals the 3 kills the 1/3 pi times 1/4 times h squared dh dt. And now I just plug in the stuff I know. I know the height is changing at a constant rate of negative 3 over 10. So actually I did know dh dt, and what I'm solving for is dv dt. I plug in h equals 5, so this is 25. And I just solve for dv dt. If you do that, you get what? Negative 75 over 40, which would be our hunky-dory answer to this one. Does that simplify? Yes. What does it simplify to? Negative 15 over 5? Wait, is that right? No, negative 15 over 8. That's right. Or negative 1.875. And that would be that. And then the last part says, show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. This is a more complicated idea. So my exposed surface area of the water equation is pi r squared. That's that. That's it. So that's one of the things. So I'm saying that something is this is proportional to the rate of change of the volume of water in the container. So this actually required us to go a different direction with this. It required us to go the h equals 2r direction with our original rewrite of the equation. So I'm going to wipe out my steps for B here. And I'm assuming this is the section on this free response question that a lot of people got wrong, because this requires some extra thinking here. So instead of V equals 1/3 pi r squared h, I'm going to get V equals 1/3 pi r squared times 2r. I'm going to combine like terms, and then I'll take a derivative. 2/3 pi r cubed. No f's yet. Seems good. dv dt is the derivative of this, and it's equal to 2 pi r squared dr dt. Okay, so now here's the fun part. K pi r squared is something that's proportional to this exposed surface area. And 2 pi r squared dr dt is my derivative. The irony of losing sound right as I was bragging about how I hadn't lost sound. Hopefully I'm back with the good old unplug replug strategy. I'm going to wait a second and make sure I'm back. People are still saying F. I can hear the audio now, don't worry. Cool. So in this question now, I have, here's my area equation, and I multiplied it by k because it's proportional. And 2 pi r squared dr dt is my rate of change of the volume with respect to the radius. So now I just set these two things equal and solve for k. So r squareds cancel on both sides, so that's pretty chill. Pi cancels on both sides, so that's pretty good. So k is just 2 dr dt. You are back. F stands for the audio is working. Am I trusting Michael now? Or am I trusting TJ? You are back. Okay. Now all I have to do is solve for dr dt, and now comes another little bit of nuance. If I take the derivative of my ratio, I get that dr dt equals 1/2 of dh dt. So dh dt is negative 3 over 10, so dr dt is just negative 3 over 20. And that makes my k proportionality constant just exactly my rate of change of my height, which is negative 3 over 10. Booyah! I'm sorry about the sound issues. I hope this was actually helpful to see a lot of the stuff in this question. This question like dissects cone questions. We do all of the everything. I took the derivative of the ratio of their comparison, the radius and the height. I took the derivative with respect to r, with respect to h, and solved for all the parts. My k ended up being the same as my dHdt, which makes this a really cool question. If you have any questions on anything further, I really hope to help you in person, because the stream was a bit of an adventure. We have 2 parts, and they're even filled with the stream chanting F as I lose sound. So I really apologize for the technical difficulties today. It's so depressing because the last stream was so good as far as technical stuff went, and then I updated OBS, and then everything went to heck in a handbasket. No, don't end it. Do 25. I can take a quick peek at 25. It's just my voice is dying from talking all day and doing this. It turns out it's tiring. Hence the coughing. 25 is a baby implicit one. So I'll mob this real quick, because that's no problem. If you take the derivative implicitly, you get cosine of x minus, because our cosine is going to become negative sine, 65 sine y dy dx. If you're like, why the heck did you get 65? It's because I changed out this 13. And that equals 0. And now all you do is get the dy dx terms on one side and everything else on the other side. So cosine of x equals 65 sine y dy dx. And then just divide by the stuff. So cosine of x over 65 sine y equals dy dx. And so this question exhibited some implicit differentiation, some chain rule, but no product rule or quotient rule or any of that stuff. Alright, folks, sorry about the bad stream. I'm sorry everything was so disastrous. Sorry about the coughing at the end here. My voice is shot. I hope you guys have a wonderful night. I hope if you have any questions that you bring them to my attention tomorrow. I'll be there after school. I run tutoring, so I'll be there for an hour and a half after school tomorrow. At the least, you can also come in Wednesday morning before the test if you want to ask questions. I'll be there. I would like to help you understand any of this before we get to the test time. and have a wonderful night. Bye bye.